we're asked to decide whether each of these are equal to one another. So starting with the first item, these are clearly equal to each other. Doesn't matter the letter. This is 1 plus 2 plus 3 all the way up to plus 10. This is 1 plus 2 plus 3 all the way to plus 10. So yes, these are equal to one another. This next one's not as easy though. The real trick to these, you could figure out these summations, but that'd take a while. It's better to do them by trying to rearrange them and rewrite them. So I'm going to distribute that j just to look at this. This is sum from j equals 1 to 10. And this is j squared minus j. And then this one, sum from k equals 0 to 9. That's k plus, I'm distributing. That's k squared. K squared. Okay, so we can take each summation, do them separately. The sum of j equals 1 to 10. We can use this formula. The sum of I equals 1 to some number n. N is 10 in our case. That's going to be, when it's I squared, it follows this formula. That's a quick computation. So for this one, when we sum from 1 equals 10, we're plugging in 10 in for n. So that's going to be 10 times 11 times 22 plus 1, so times 23 over 6. And then we're going to subtract it. This is also by the summation of j. The sum from I equals 1 to n of I is just n times n plus 1 over 2. So those are just summation formulas you can quickly Google. My handwriting is terrible. So this is going to be 10 times 11 over 2. So if we do that, it's 10 times 11 times 23 divided by 6. Oops, I got something wrong here. My mistake right here. When I plugged in 10, 2 times 10 is 20. 20 plus 1 is 21, not 23. So 10 times 11 times 21, because it should be divisible by 6. That's how I knew I got something wrong. So that's 385. And then 10 times 11, that's 110 divided by 2, so that's 55. So the first summation is going to be 330. Okay, you can do the same thing over here, except look, these formulas start at 1. This one starts at 0. But look at what the 0 term is. If you plug in 0, 0 squared plus 0 is also 0. So it's this formula that we have over here is equivalent to this formula. Okay, so using the same formulas up above, that's 9 times 10 times 18, 19 divided by 6. So that's 285 plus, this is 9 times 10 divided by 2 plus 45. So we got 330. Okay, so this one works because this is 330 and this is also 330. That one took a while. I tried to think of an algebraic trick to simplify it, but I got nothing. I think you just have to do those ones out. This next one, though, is going to be a lot quicker because they just want you to practice distributing and then rewriting the summation. So this first summation over here, you can distribute the j. That's j squared minus j. That's the same thing as k squared minus k. So these two are going to be equal to each other. This one down here, I think we just have to compute the summations. This one, from j equals 0 to 10, same thing. We can say that's the same thing as j equals 1 to 10 because plugging in 0 into the summation just gives you an adding 0. So the left summation is going to be 10 times 11 divided by 2. So that's 55. And then this right one doesn't start at k equals 1, so we just have to rearrange it a little bit. Start at k equals 1. But in order to make it equivalent, we got to subtract something outside the summation. So this is what we're going to sum. We need to subtract the k equals 1 term. If you plug in 1 in here, 1 plus 1 makes 2. So that way, this summation, and this expression, I should say, is equal to this expression. Right? We can make it k equals 1, but if they're going to be equivalent, I've got to subtract the k equals 1 term so that it actually is starting at k equals 2. So I've rewritten it so that these two are equivalent. Now I can compute the summation. This first one, sum from k equals 1 to 12 of k, that's 12 times 13 divided by 2, so that's 78. And then look here, the sum of 1 From k equals 1 to 12, that means 1 plus 1 plus 1 plus 1, 12 times. In other words, it's 12 times 1. So that's going to be 12. And then we need to subtract 2 from the end. So that's 88. So those two are non-equivalent. I got 55 for the first one, 88 for the second one. Oh, this one starts at k equals 6. It's kind of yucky. That one you have to back up a lot. That one might be easier just to do by hand. Okay, so j equals 1 to 10. We just did that. That's 55. So let's check to see if that's equivalent to this one over here. So look, start writing out the partial sums, meaning plug in k equals 6, see what you get. 6 minus 5 is 1. Plug in 7, you get 2. Plug in 8, you get out 3. Plug in 9, you get out 4. Right? So how many times would we do that? There's 10 terms here. 6, you got 6, you got 7, you got 8, you got 9, you got 10, you got 11, you got 12. I'm hitting plus, but so I think that's 10 times. We could keep track of it that way. 6, 7, 8, 9. I guess I'll just write it all out. 10, 11, 12. This k equals 13. K equals 14. K equals 15. Oops. 7. I started writing down the term I was on. That's 8, 9, 10. Because if you plug in 15, 15 minus 5 makes 10. If you plug in 14, you get out 9. So these are all the terms that we're summing. We got 55, so those two look to be equivalent to one another.